Alright, hey guys, Mr. Brading back here to finish up on the physics talk, the first physics talk here, and I'm on gravity, mass, weight, Newton's second law. What I've already have explained in the previous lecture was how to calculate for force, mass, and acceleration, and just the basic steps that you need to go through. Make sure you watch that video before you watch this one. On the test, there's going to be like 7 questions or 8 questions where you're going to be calculating for force, mass, or acceleration. So it is pretty darn important that you watch that last video. This next video is really going to just mostly help you out with the challenge that you do next week. Okay, so when you guys did the investigate, you noticed that there was gravity. Gravity is in fact a force, and that's why we say, oh, the force of gravity, yes, okay. And gravity will accelerate anything or everything at a rate of 9.8 meters per second squared. Okay, now this isn't always exactly true because there is also some other things going on, like there's the air resistance that can hold things up. So if you have like a guy parachuting or something, when he's in free fall, he'll actually accelerate at 9.8 meters per second squared, but he pulls that parachute and the parachute actually pushes up, and so the rate of acceleration drops dramatically. Okay, so let's say again, I think I discussed this yesterday or whenever I did the last video, that the force of gravity, again, it is related to its acceleration. And so let's say if something is 1 kilogram, then the force of gravity pulling down is actually going to be 10 newtons. Or actually, if you want to be exact, 9.81 newtons. And so they explain that here. So if you drop a 1 kilogram mass, it accelerates at 9.8 meters per second. Now if you did this, it'll put a dent in my floor, so don't do that. But just for example's sake, that anything that's 1 kilogram, it actually has a force, or it's going to be pulled toward the earth with 9.8 newtons of force. Okay. Let's see. And right here they're talking about weight. Now whenever we talk about mass, mass has to do with how much matter is in an object, whereas weight is the actual force of gravity. And you can see F equals ma. It is force equals mass times acceleration. Now you can think of the force of gravity is the weight, and so you can replace force of gravity with W, and then mass times the gravity, which mass times the gravity, and gravity is always 9.8 here on Earth anyways, so your weight is always equal to your mass times the gravity of the Earth. So that's just kind of a fun little fact. Balanced, unbalanced forces. Yeah, I talked about this a couple videos ago whenever I talked about Newton's 3 laws of motion. Again, another video, if you haven't seen it, you need to go back and watch it. And we can always actually show forces on what's called a free body diagram. We can actually, so you can see here, okay, there's a red arrow and a blue arrow. So you can see that, okay, if there is a force here and a force here, so the force of gravity, if the force of gravity is equal to that of the one of the hand holding up the actual apple here, so you have a hand pushing up and the gravity pulling down, there is actually a net force of 0. It is a balanced force. Thus, the apple will not accelerate in any direction at all. Now, if, let's say, this person was holding 100 pounds, maybe they can't provide the same force that gravity is pulling it down with, and so the weight will actually start to accelerate downward. On the contrary, if you have a weight and you're pushing up with a greater force than gravity's pulling down, then the weight will accelerate upward. Alright, and I think that is the very, very end of that physics talk. If you guys have any questions, make sure you write them down. Other than that, I'll see you guys next time.